welcome to this lesson. So in this video, we shall continue by looking at network topologies. Okay, so we shall continue by looking at network topologies. So the first thing that we're going to look at is to define what a topology is. So what are topologies? What are network topologies? So network topologies, these are laid out on how networks communicate with different devices. So network topologies are laid out on how networks communicate with different devices. So the way different devices are able to communicate creates what we call a topology. Okay, now there are two types of network topology. There are two types of network topology. We have wired topology and wireless topology. Now, when you talk of wired topology, there are types of wired topology. We have star topology, ring topology, bus topology, and mesh topology. That is just part of the wired topology. Okay, and then we also have wireless topology. So under wireless, we have infrastructure topology, ad hoc topology, and wireless mesh topology. Okay, so to start with, like you are able to see here, the way you are able to see how it is listed. So the first point was, what are network topology? That was the first thing. You have to define what network topology here. So the first point emphasizes on the definition. Okay, so the first point emphasizes on the definition of a network topology. So a network topology is defined as a layout on how networks communicate with different devices. So a topology is a layout on how networks communicate with different devices. And then later on, we are looking at the types. Okay, so we're looking at the types of topologies. So under the types of topologies, we have two types of topology. We have wired topology and wireless topology. So under wired topology, we have star topology, ring topology, bus topology, and mesh topology. And then when you look at the wireless topology, where you don't need to use physical cables to connect these networking to an internet, you just need, these are wireless. So under here we have infrastructure topology, ad hoc topology, and wireless mesh topology. Okay, so now let us now proceed by looking at these types of topology one by one. So we're going to start with star topology. Okay, so we'll start with star topology. Okay, so let's look at star topology and what is involved. We look at star topology, which is part of the wired topology. Okay, so remember we started by defining a network topology, where we said that a topology is a layout on how network communicates with other devices. So a layout on how network communicates with other devices creates what we call a topology. So let's look at the common ones, which are wired topology. We'll start with star topology. Okay, so we're going to start with star topology. Star topology. Okay, topology. So star topology. So under star topology, okay, so under star topology, this is what is really needed. Okay, so what you're supposed to have at the center is, it can either be a hub, okay, you need to have a hub or a switch. Okay, so the first thing that you're supposed to have when you are dealing with star topology is you need to have a hub or a switch. Okay, when you have a hub or a switch, now you connect those machines that you have, computers, to that hub. Okay, so you connect the machines that you have to the hub. Okay, so we have this is the hub. Okay, so this is the computer, so we have computer one there, and then we have another computer, and then we also have this other computer here, we definitely have another computer here. Okay, so we can put it as this is client 1, okay, this is client 1, and then we can also put it as this is client 2, and then we have client 3, and then we can say this is client 4. Okay? Now, when you look at this diagram, the only thing that we have at the center is the hub. Remember, we are dealing with star topology. Okay? We are dealing with the star topology, which is one of the examples of wired topology. So under star topology, we have a hub at the center. So this is the hub at the center. So you can either use the hub or you can use a switch. Okay? So all these four machines, all these 4 computers are connected to a hub. Okay? So all these 4 computers are connected to this hub. Okay? So meaning these 4 computers depends on this hub. Okay? So one of the advantages when you talk of the merits, okay? When you talk of the merits of a star topology, one of the advantages of star topology is that, let's say in an instance, one of these computers disconnects from a network. Let's say, for example, computer 3 disconnects. Okay, so if computer 3 disconnects from this network, okay, if computer 3 disconnects from this topology, the networking will still continue. Meaning these 3 computers will still be communicating. Okay, these 3 computers, computer 1, 2, and 4, will still be communicating, even if computer 3 is not connected. Okay, maybe you have a cable interruption. So if there is a cable interruption in one of these computers, it means that still the networking will still be taking place. Okay, so the networking will not be affected. That is one of the advantages of star topology. If any of this computer is disconnected to the network, what it means is that it will not be affected. Networking will still continue. Okay. Now, the disadvantage of a star topology is that the star topology depends on the hub or the switch. A star topology kind of networking depends on the hub or the switch. So the moment the hub or the switch is interrupted, meaning even the other 4 computers that are connected to the network will be interrupted. Okay, that is one of the disadvantages. So the disadvantage is that if the hub stops working, if this hub stops functioning, meaning even this computer that surrounds the hub, which are connected to this hub or the switch, will also stop functioning. That is one of the disadvantages. But the advantage is that if any of this cable for these computers is interrupted, the network will still continue. But the disadvantage is that if the hub or the switch is not functioning, it means that even the computers that surround the star topology will be affected. In short, the computers that are connected to the hub or the switch, they depend on the operation of the hub. So if the hub stops functioning, meaning even the computers, even the network will be interrupted. Okay, remember we were looking at star topology. Okay, now let us continue and let us proceed by looking at ring topology. Okay, so this was just star topology. So we proceed by looking at the diagram for ring topology. So we proceed by looking at the diagram for ring topology. So the diagram for ring topology. Okay. So ring topology. Okay. So under ring topology, we expect the machineries, the computers to be connected to a network in a ring. Okay. So we expect the computers to be connected in a ring. Okay, so we can put these client computers. Okay, so we have this other one is another computer, and then we also have this computer here. We also have this computer. So these computers are connected to each other in a link. Okay, they are connected to each other in a link. Okay, they are definitely connected to each other in a link. Okay, so these computers are connected to each other in a link. Okay, so that is link topology. So they are connected. So we have, we can say this is client 1, this is client 2, and this is client 3, and then this is client 4. Okay, now when you look at these 4 clients, so these 4 computers are connected in a link. Okay, so these 4 computers are connected in a link, and these computers depends on each other. So these computers depends on each other. Okay, so now when you look at a link topology is a odd way of networking. It is an odd way of networking. Okay, so currently it's not that commonly used in these companies and large organizations. Okay, but it is part of the types of topology. So it's an odd way of networking machines or computers. Okay, so but it has got advantages, and one of the some of the advantages of a link topology is that it is easy to install. You can easily install link topology kind of networking. It can easily be installed and then also troubleshoot. It is easy to find the problem that is causing any interruption in the networking. So if there is any interruption in the networking, you can easily troubleshoot the link topology. Okay, those are just 2 advantages. So the first advantage is that it can easily be installed. You can easily install the link topology, and then you can also troubleshoot. But when you look at the disadvantage of link topology, the disadvantage is that since these computers under link topology, they are interdependency. They depend on each other. Let's say, for instance, if computer 3 is not working, client 3 is not working, meaning that the process within this networking will be affected. And then we can also put it, we can also give an example. If this cable within the link is disturbed, if this cable within the link is disturbed, maybe it is cast somewhere. Okay, if this cable is interrupted and it is cast somewhere, meaning everything within the network is also affected. Everything within the network is also affected. Okay, so that is the disadvantage of link topology. Okay, so you are able to see the diagram. That is link topology. Now let us also proceed by looking at another type of wired topology, which is bus topology. So let us also look at the diagram for bus topology. Okay, bus topology. We look at the bus topology. Okay, so let's look at the bus topology. So the diagram for bus topology. Bus topology. Okay. So bus topology. So bus topology, this is how it is arranged. Okay, so bus topology, okay. Let's try to show something that will look that neat and straight. Okay, so we're looking at bus topology, and okay, at the far end here we have got the terminals. At the far end here we have the terminals. So remember, the bus topology has got terminals at the end. It has got terminals at the end. So we have okay, so we have this client computer here. We have this client computer here, and then another client computer which is connected here, and then we have this client, another client computer which is connected here. So we can say user 1, okay, user 2, user 3, and then we can say user 4. Okay. Now this is the arrangement of computers within the bus topology. Okay. So when you look at bus topology, the connection of computers depends on this line. It depends on these terminals. So at the far end, there is what we call terminals. Okay, so these terminals prevent signal reflections. So the terminals on the bus topology prevent signal reflections. They prevent signal reflections. So we have user 1, user 2, user 3, and user 4 on the bus topology. So now the computers are connected to the bus topology by the use of the causal cable. So the these 4 computers are connected to a bus topology through a causal cable. So they are connected. So the connection is through the causal, okay, the causal cable. Okay. So the connection is through the causal cable, and then the causal cable are connected to the terminal bus through the BNC connector. Okay. So these causal cables are also connected to BNC connectors. Okay. So BNC connectors. Okay. So the BNC connectors enables the causal cable to access the networking. Okay, so there are 2 important parts here under bus topology. So the computers are connected they are connected to a network through a causal cable, and then these causal cables are connected to the network of terminal bar through the BNC connector. Are we together? Definitely. Okay, indeed. And then, so now what normally happens is that one of the disadvantages of bus topology is that if these terminals that are inserted at the end, if these terminals, this T and the other T, if these terminals is loose, okay, so if the terminals are loose or if the terminals are not there, so if, let's say for instance, the terminals are not there, and then also terminals are not there. So what is going to happen is that if the terminals are not there on the bus topology, there will be reflections of the wave, the vibration. So there will be reflection of the wave. So these reflections of the wave affect the transmission of data. So when the terminals are not part of the bus topology, it brings the aspect of signal reflections. And if there are signal reflections, meaning it will affect the transmission of data. So the terminals at the far end of the bus topology help to prevent signal reflection. Because if there is signal reflection, meaning the networking will be interrupted within the bus topology. The networking will be disrupted under the bus topology. So these are signal. Okay, so we call them signal reflections. Okay, signal reflections. Okay, so those are called signal reflections, and then if there is any signal reflection within the bus topology, it will definitely affect the network. Okay, so we proceed also by looking at the mesh topology. Let us proceed by looking at the mesh topology. Mesh topology, the diagram for mesh topology. Very important. Okay, so this is what is involved when you are choosing the type of networking. If you want to do any networking, you need to choose. Are you going to deal with wide topology or wireless topology? So let's look at mesh topology. Mesh topology. Okay, mesh topology. Now, when you talk of mesh topology, this is how it works. Okay, so we have these computers, we have another computer on the other side, we have this computer on the other side, and we have this computer on the other side. So under mesh topology, all the computers are connected to each other. Okay, so we can say user 1, user 2, we have user 3, we have user 4. Now when you look at this, so all the computers are connected to each other under mesh topology. Okay, so this computer is connected to this computer, and this computer is connected to this computer, this computer is connected to this one, and this computer is connected to the other one. And then also, this computer is connected to this computer, and this computer is connected to another computer. So this is how the mesh topology operates. So all the computers are connected to each other. All the computers are connected to each other under mesh topology. Okay, so since all computers are connected to each other, it is, it is very easy to prevent failure. It is very easy to prevent failure in a mesh topology. Let's say, for instance, there is a problem in this cable that connects this computer to this computer. So whether this cable from this cable is not connected, this computer here and this will not be affected. It will still receive the transmission of data from other wires. You get the point? So this is the reason why we are saying that it is very difficult to prevent the operation of computers within the mesh, because the mesh has got a lot of cables connected to each computer. And so in a case where this line is not working, this cable is not working, definitely all these computers will still receive information from another computer, because of there are a lot of cables that are connected to each other. So this is the reason why we're saying that it is very easy to prevent failure when you're dealing with mesh topology. Okay, so now when you look at the disadvantage of mesh topology, the disadvantage is that mesh topology is very expensive. Mesh topology is very expensive because you need a lot of cables to connect it. You need a lot of cables to connect it. So it is very expensive as compared to other types of topologies. Are we together? Okay, so we have talked about the 4 wired topologies. Okay, we have talked about the 4 wired topologies. Now let us also look at the wireless topologies. We look at the wireless topologies. Okay, let's also talk about the wireless topologies and their diagrams and structures. Okay, so we look at the wireless topologies and their diagrams. Okay, so we're dealing with wireless. Okay, wireless topology. Okay, wireless topology. Now, under the wireless topology, we have 3 main types. We have infrastructure topology, and we have ad hoc topology, and then we have wireless mesh topology. So let us start by looking at infrastructure. Okay, so we start by looking at infrastructure topology under the wireless. So we have infrastructure. Okay, so we have infrastructure topology. Okay, so under infrastructure topology, we have the machine here, the computer, which is connected to a hub. Okay, so it is connected to a hub. So now these computers which are connected to a hub, it's more like we're dealing with a star topology. So these 2 computers that are connected to the hub, this same hub needs to be connected to the access point. It needs to be connected to the access point. Okay, the access point, that's where now we need to access the networking. Okay, now this access point, this access point is wireless. This access point is wireless. So we have got, maybe we have user 1, we have user 2. So here we are dealing with wireless topology. So here we are dealing with wireless topology. So under wireless topology, we are looking at infrastructure topology. So under the infrastructure topology, we have the first part. So the first part is that these 2 computers are connected to the hub. So these 2 computers are connected to the hub physically. So they are connected to the hub physically, meaning there are cables that are inserted on these 2 computers. Okay, so there are 2 cables that are inserted on these 2 computers connected to the hub, and then the hub is connected to the access point wireless. Okay, so it is connected to the access point wireless. Okay, so there is no physical cable that is existing. There is no physical cable that is existing in between the hub and the access point. It is wireless. So this form of connection, wireless and wireless, wireless point is called infrastructure topology. So under infrastructure topology, we have the users, which are the computers connected to the hub, and then the hub is now accessing the network through the access point. It is accessing the network through the access point, and the access point do not have a physical connection. So this kind of connection is what we are calling infrastructure topology. Are we together? Okay, definition. So now we proceed by looking at another wireless topology. We proceed by looking at another wireless topology. Okay, so another wireless topology is ad hoc. Okay, so we have ad hoc. So we have ad hoc topology. Okay, ad hoc topology. So we have ad hoc topology. Now under ad hoc topology, here you don't need any physical infrastructure. We don't need any physical infrastructure. Let's say, for instance, you have a computer here, you have a smartphone here. Okay, so this is a smartphone. Okay, you have a smartphone here, and then you have user. Okay, user, this is a computer. And then here you can have, we can say this is the access point. We can say this is the access point. Okay, so that is the access point. So meaning all these smart devices, we can also have a camera here. We can also have a camera here. So this can be a camera, okay, a smart camera. So we can also have a smart camera there. So what is going to happen is that user, which is the computer, and the smartphone and the smart camera, they will be able to access the network. They will be able to access the network without using the physical cables. So they will be able to access the network on their own. Okay, so since they are able to access the network on their own, this type of wireless topology is called ad hoc topology. Ad hoc topology. So they are able to access the network on their own. But the only issue is that since they are able to access the network on their own, they will provide their own security. Okay, their own security. So since they are providing their own networking, they will provide also their own security. Are we together? So that is just the ad hoc, where the smartphone will be also able to connect to the internet or to the network, and then the camera will also be able to access the network, and then also the computer will also be able to access the network wireless without using of any physical cable. Okay, definitely that is the ad hoc topology. Okay. Now, let's also look at the last one from the wireless topology, which is wireless mesh topology. Okay, so wireless. Okay, so we have wireless mesh topology. So under the wireless mesh topology, mesh topology, here it is common to the wired topology. But the only difference is that there are no wires that are involved under wireless. Okay? So, wireless mesh topology is common to wired topology. But the only difference is that under wireless, there are no physical cables that are involved. So, what I'm trying to put across is that we can have, this. So we can have a hub here, or access point. So we can also have access point in here. So this is also here we can have access point. Okay. So even here we can have access point. Okay. So these are 4 different access points. So what is going to happen is that these 4 access points are connected to each other without using the physical cables. These four access points are connected to each other without using the physical cables. So what will happen is that, for instance, at Churchlife University, we have different places where you can actually access your network connection, your internet. So let's say for instance, this is point A, and then we have point B, and then this is point C, and then we have point C. Okay, this is point D. So what is going to happen under wireless mesh is that since there are no physical cables that are involved here, okay, so a person can also decide to connect to the internet using their phone, using their laptops. They can also connect to point A, and then they can also connect to point B. So the moment they move to point B, they will not face any challenges because this point A are communicating with point B in a wireless form. Again, they can also connect, as they reach to point D, they can also connect to point D without using any physical cable. So when they also reach point C, they can also connect to point C because those 4 access points are communicating by using wireless. Okay, so they are communicating in a wireless form. There are no physical cables that are involved when you are dealing with wireless mesh topology. Are we together? Okay. I hope you have enjoyed the video. Remember, we started by defining a topology, and then we looked at the types of topology, and we did all the diagrams and the structures and all the demonstrations that are needed. Thank you for your time and enjoy. Don't forget, don't miss the next video. Enjoy. Thank you.